Speed of 19 meters per second from a standing start. So reach to speed, so that's VF, 19 meters per second. From a standing start, so that's VI. In a period of 2 seconds, so that's T. What was the cheetah's acceleration? So very same procedure as we just did. A is equal to VF minus VI divided by T. So we just plug in what we know. And we're not told direction. Oh yeah, it says assume the cheetah runs in a positive direction. 19 meters per second minus 0 meters per second, all divided by 2.0 seconds. So 9.5 meters per second squared, and that's already in sig digs, and then we just put positive direction.
Also, if it just says positive, in a positive direction, we just put like PD or something?
No. Because that could mean professional development.
Well, you just go like
No, but you don't know it's east. It could be north. North is also a positive direction. Up is a positive direction. So all we can just put is just positive direction.
And right's positive.
And right's positive? Yeah. Yes?
Will there be any questions everyone where you have to find out like what VI is?
Yes, so that's what we'll be doing next. That's the next example. So ready to go on? Okay. Okay, last one. The acceleration of the space shuttle at takeoff, so the acceleration at takeoff is, so we know the acceleration is 29 meters per second squared. What is the shuttle's velocity after 12 seconds? So VF is our question because it's after, meaning final. We assume that the space shuttle was at 0 meters per second to start with.
So would it always be 0 unless it tells you otherwise?
And the time is 12. Yeah. Okay. So we write out our formula. Now, I'm going to show you a trick. So this makes the rearranging easier. Okay? So VI is 0. So I'm just going to cross it off. It's 0. If it's 0 and it makes it easier for rearranging, just take it out. So if I rewrote this, I could say A is equal to VF divided by T. Do you see that? I just took it out because it's 0. Don't need it. Now you can make your triangle to do your rearranging. So in a triangle, the fraction part, whatever's on the top of the fraction, goes where? The top of the triangle. So that's how you know. Everything else goes on the bottom, and it doesn't matter which side. So the top of the fraction goes on the top of the triangle. Okay. So now,
Do the V's have to have arrows on them?
oh yeah, thanks. I didn't forget that.
The V's have to have arrows on?
Yeah, if we're being really diligent. So now what are we looking for? We're looking for VF. So what's my formula then? VF is equal to A times T. Okay?
It has a little arrow on it too.
That's right. Yes, it does. Thank you. So A times T. So now we just plug in the information that we know. So VF is equal to 29 meters per second squared multiplied by 12 seconds.
Would the seconds cross each other off?
They do, well, one of them does. So it's like, here, since it's squared, so now look at what I end up with, meters per second, which makes sense because it's a velocity, right? So,
I thought we were looking for VI.
How do you rearrange it if VI wasn't 0?
I can show you that too.
Oh, we might put it in Cindy's.
Yeah, we do. I can show you, Amy, but you won't have to.
You won't have to ever?
That's right. I just won't give you that complexity of a question yet in science.
I was wondering if you had.
Yeah. Okay, so our answer, 348 meters per second. But we need this in sig digs. We're only allowed 2 digits. Hi.
3.4. It's a 2? 3.5.
Because you look at the digit, your last digit, and you have to round up. How many decimal places did I move? 1, 2. Meters per second, and what's my direction? Up. This, I'm pretty sure the last time I checked, space shuttles go up, yeah. It's like on, I always think of on True Grit, the new one, when he's like, I always go backwards when I'm backing up, you know? You know that? When he says that? Rooster Cogburn? He's being interrogated in the court, and he's like, which direction were you going when you were backing up? He's like, oh, let's go backwards when I'm backing up. It's like, it's my best line. It's my favorite.